This is part 1 of the chapter 6 test review. I'm probably going to go through the first half of the test and then make a second video for part 2. So for numbers 1 through 3, we're trying to identify the domain. For all of these rational expressions, we're trying to look at when the denominator is going to be equal to 0, because that's when the rational expression is going to be undefined. So I'm setting the denominator equal to 0. I would subtract 1 on both sides to get x equals -1. So I want to say that the domain, what my possible inputs could be, are going to be all values, right? When they say all reals, we're talking about all the numbers x could be, with the exception of -1. So for 1, it's going to be a. For 2, I'm setting -4x plus 8 equals 0. I would add 4x on both sides. I'm going to divide by 4 to get x equals 2. I don't have to worry about what's going on in the numerator. I just want to figure out when would the denominator be equal to 0. So I'm going to say it's all real values, all reals except x, or except 2. Sometimes in the book and in other math classes, they might put like x cannot equal 2 to show that same idea. For this next one here, I've got 4x plus 8 over x squared minus 9. Again, we're looking at the domain. So when I set x squared minus 9 equal to 0, you can either solve this by adding 9 on both sides, taking the square root and saying x is equal to plus or minus 3, or we could factor. It's the difference of perfect squares here. And then set each factor. Oh, sorry, I didn't mean to write 9. X plus 3. X minus 3 equals 0. X plus 3 equals 0. X equals 3. X equals -3. So in this example here, the domain is going to be all reals except -3 and 3. -4. For this next one, they want us to simplify the expression. When you're adding in or subtracting in the numerator, we can rewrite this like we're subtracting 2 different rational expressions here. So this could look like 4v squared divided by 2v minus 14v over 2v. 4 over 2 is going to be 2. V squared over v is v. We're subtracting 14 over 2v. This is going to be 7, and v divided by v is equal to 1. So my final answer is going to be 2v minus 7. This one says simplify each and state the excluded values. So for here, this is almost like looking at the domain from before. Right now, I just want you guys to simplify. On the actual test, I'm not going to have you state the excluded values. In the rational expression here, I've got m squared minus 8m plus 7. I'm hoping that I can write that as the factor of 2 binomials. And it would be nice if it was m minus 7 times something. So I'm looking for 2 numbers that multiply to a positive 7 that combine to a -8. The fact that it's m squared tells me that this is going to be m times m, and that it's a negative number that they're combining to tells me that this is both going to be subtraction. So 2 numbers that multiply to positive 7 would be -7 and -1, and we're dividing by m minus 7. In the same way, if I had 3x divided by 3, and this is equal to 1x, if I have m divided by 7, m minus 7 times m minus 1 over m minus 7, the m minus 7 and the m minus 7 are going to cancel, and I'm left with m minus 1. For number 6, I have r squared minus 16 I'm dividing by 4 plus r. So I could rewrite this like r squared minus 16 over r plus 4. When I'm adding in the denominator here, the order is not going to change, right? I couldn't write this the same as 4 minus, if it was 4 minus r, that wouldn't be the same as r minus 4. But because it's addition, this works. So again, I see the difference of perfect squares, r minus 4 times r plus 4 divided by r plus 4. These cancel, I'm left with r minus 4. All right, and number 7, I am multiplying the two rational expressions. In the numerator, I'm looking for two numbers that multiply to a negative 14 and combine to a positive 5. When I think about numbers that multiply to 14, I've got 1, 14, 2, and 7. Because this is a negative, I'm going to write 7 and then 2 and 14. Because looking at the scenario where it's a negative 2 and 7 is a different outcome than if it was negative 7 and 2. So two numbers that multiply to negative 14. Oh, I forgot to put the 1. And then combine to a positive 5. I need to look at the examples where the positive number here is larger. So I can cross out negative 7 and negative 14. This would be negative 2 and positive 7. X minus 2 times plus 7. Now if it's 6x plus 42, I'm going to factor out a 6. This becomes x plus 7. It would be useful for me because I'm seeing that I've got the x plus 7. You got x plus 7 and x plus 7. It'd be nice if I had some version of x minus 2. Now here, when it's 2 minus x, if I were to change these signs to make x positive and the 2 negative, I could factor out a negative 1 and get negative 2 plus x, or I could write that in the denominator, negative 2x minus 2. Again, there are some people that like to multiply and then cancel things out. I think it's easier to cancel. Whether we're talking about the factors in the same rational expression or in the other two here, like the x minus 2 and x minus 2, those cancel, and I'm left over with negative 1 over 6, or 1 over negative 6. All right, at number 7, I got 4b squared times b squared plus 2b minus 3 over b squared minus 6b minus 27. All right, in the numerator, 4b squared over b minus 1. Two numbers that multiply to negative 3 that combine to a positive 2. That'd be b plus 3 times b minus 1 over and if I'm looking for two numbers that multiply to negative 27 that combine to a negative 6, I know it's going to be b minus and b plus. So factors of 27 would be 1 and 27, 9 and 3. So it's minus 9 plus 3. I see b minus 1 and b minus 1, b plus 3 and b plus 3. These are going to cancel. I'm left over with 4b squared and then b minus 9. For number 9, it is 10 plus 90 divided by n minus 3 divided by n plus 9 over n plus 3. I had A over B divided by C over D. Some people were taught like the keep, change, flip. I like to think of it as changing to multiplication, and now multiplying by the reciprocal. Reciprocal is a fancy way of saying that this fraction is flipped. What was in the numerator is now in the denominator. What's in the denominator is now in the numerator. So I'm going to rewrite this like 10n plus 90 over n minus 3 times n plus 3 over n plus 9. Factor out the 10, n plus 9 over n minus 3 times n plus 3 over n plus 9. Here, if I see n plus 9 divided by n plus 9, I know that those are going to cancel. N plus 3 is different than the n minus 3. So those can't cancel. But I'll be left over with 10 times n plus 3 divided by n minus 3. And then for number 10, 4a squared over 8a. You could divide this through to get 2a and then divide that, but I'll just keep that for right now. This is 10a cubed plus 20a squared over 20a cubed plus 40a squared. Let's factor out in the numerator 10a squared to make it a plus 2 over, this should be 20a squared, and it's a plus 2. So a plus 2 and a plus 2 cancel. A squared and a squared cancel. This is 1 over 2. This is also 1 over 2. And a divided by, or a squared divided by a is going to be a. For number 11, I've got a squared minus 12a plus 20, and I'm dividing by 2a squared minus 20 over 2a squared minus 4a. Sorry, 20a minus, and the other one was 4a. So in the first rational expression, two numbers that multiply to 20 that combine to a negative 12, they both need to be negative. So it's a minus 10 and a minus 2. In the denominator, same idea, two numbers that multiply to a positive and then combine to a negative. This is a minus 2 times a minus 1. Now if I'm dividing, I'm going to change this to multiplication, and I'm multiplying by the reciprocal. I can factor out 2a from a minus 2 in the denominator, which is now in the numerator, and I can factor out 2a minus 10. 2a and 2a cancel. A minus 2 and a minus 2 cancel. A minus 10 and a minus 10 do as well. And I'm left over with a minus 2 over a minus 1. All right, I'm going to do one more, and then I'll make the rest of this in the second part. When we're adding the rational expressions, like when we're adding fractions for like 1/4 plus 1/3, I need to have a common denominator. The fact that I'm adding these up and both denominators are 9x squared plus 9x tells me this should be 9x squared plus 9x. Here, if I add x plus x, well, I'll write it this way. So for some people, it helps to see this out as x minus 1 plus x plus 4, or 2x minus 3 over 9x squared plus 9. Alright, so that's going to be it for the first video. If you have any questions, let me know. And I should be posting the second video tomorrow.